So keep writing, and as you're writing, listen. This is the second part, or the last tiny little part of 6.1. And then we're going to try to get in as much of 6.2 as we possibly can. Okay? So we've got full deck assignment. I did try to get that to happen in the last class period, and we were interrupted by a fire drill, so it didn't quite happen. I'm hoping that things go a little more smoothly this class period, and then we'll go from there. The first thing we have to do is we have to be able to write an equation given 2 points. And yesterday we did that by hand. We did the substitution. We wrote out two equations, y equals a times b to the x. If you look back at your notes for example 5, you'll see that we solved for a and b. We did a lot of that work by hand. Do you remember doing that yesterday? Okay. The deal is they don't always give us really nice, beautiful points. Sometimes they look like actual data. What is it, Leo?
What is those two right there where it says
1 and A. Okay, so right here this says 1. You're going to click on Stat Calculations. Stat Calculations. And A, after that, you're going to pick Exponential Regression. Exponential regression.
Can you scroll up?
Mm-hmm. So this is going to be kind of a group effort. Okay, I'm going to read off to you what we do when we get our 2 points. You're going to have to listen. Okay, if everybody starts talking, this is going to take forever. Example 7. What I want you to do right now is write these 2 points down. These points are 2, 24.8 and 5, 198.4. It says use a graphing calculator to find the exponential equation. That's what we're going to do when we do our exponential regression. We're finding the equation of the exponential function that goes through these 2 points. Yesterday we did it by hand. We did example 5 and the try it, and we solved it out by hand. And we solved for A and for B. That's not always so pretty with such good numbers. So in this case, that would be a lot harder. Are you following what I'm saying here? Okay, so on your calculator, go to your home screen. Go to your home screen. Remember our points were 2, 24.8 and 5, 198.4. On your home screen, you're going to push new. Okay, go over to the right, push new. And then we want to pick number 4, add list and spreadsheet. So far, so good? Go up to where you're in the box that has the A. And in that box, you're going to type an X. Enter. Do the same thing in the B column, and you're going to put a Y. Enter. Are you with me? Okay. In column X, you're going to put in your X data. So go down into row 1. Make sure you're sitting in row 1. In your X column, you're going to put the 2 and the 5.
In the same
Nope.
column?
Yeah. Row 1 and row 2.
Wait, what?
Oh, gosh.
Oh, okay, like the X.
Yeah, and your X values. And you're going to do the same thing with the Y values. So you're putting the X data in the X column. You're putting the Y data in the Y column. So far, so good. 24.8 and 194.8 or 198.4. Everybody good so far? Okay. Now, you've got both data points in there. Slide over, still in column 1. Or row 1. Still in row 1, go to column C. And in that box, you're going to push menu 4, 1, A. Y'all with me? Your X list, you're going to call X. Your Y list, you're going to call Y. And then you push OK.
What is okay?
at the very bottom, the box that says OK.
We did this last year.
You did do this last year, right? Okay, and so it just kicked out a regression for you. What is your value for A? So A equals 6.2. What's your B value? 2. So what is the function? F of x equals 6.2 times 2 to the x. Okay, F of x equals 6.2 times 2 to the x power. So given those 2 points, that's the line that runs through them, or the exponential regression. Cool? Okay, so we're going to do another one. You're going to troubleshoot, get with a neighbor, somebody that might be struggling. Y'all make sure everybody's got your, these are your 2 points. These are your 2 points, 375.98 and 481.07.
And then that's what it should be. Well, how does it all do? I'm getting 90. Just that. I did.
Okay, did it.
Did it work?
No, you put your X in
What'd we
the
get,
wrong one.
Bryson?
A is 12 and B
Don't get
is
cranky, 'cause I'm gonna get cranky.
1.8. We're just going to do the
Okay.
place.
Okay.
X and then Y over here. And then you do the 2. What was it, 24.8?
Not too bad.
I can't wait to fall back
And then 5, and then what was that mean? 1, 9, 8. Okay, and then you go to this one and you press -4, 8, 1.
Okay, so here's our next thought. This is the number E. The number E. Now, they about threw a shoe at me last class period. They said E's a letter. In this case, we're using a letter, E, to represent a number that recurs over and over and over again when we're dealing with exponential information. This number E, it says the letter E represents the irrational number 1 plus 1 over n to the nth power as n increases without bound. So if I were to run this situation over and over and over, increasing n, so I would let n be 4, and then 5, and then 6, and then 7. Eventually, my number trends toward this number E. E is called 2.718282. If I said pi, what would you tell me? 3.14. You know that we use the symbol pi to represent the number 3.14, yes? This is like that. We use the number E to or the letter E to represent the number 2.718. This was a constant name from the Swiss mathematician Leonhard Euler, is how you say that, E-U-L-E-R, Euler. Just so you know, this is the letter E. It's useful when we're dealing with logs and exponents. On your calculator, all we're going to do with this number for now is we're going to use it to get some powers. Okay, so on your calculator, you're going to type E. Look on the left column on your calculator. It's located right under the parentheses. Can you see the E to the, and it opens a box. First type E to the first power. Everybody do E to the first and push enter. What number did you get? C. It's 2.71. It's the same every time. Now do E to the 3.14 power. 23 point. Okay. Do E to the negative 0.5 just for kicks. E to the negative 0.5. 0.6. Okay. Nicely done. Anybody have any questions about that? Okay, so that's the last part of 6.1. That's the whole 6.1 lesson. Everything we do from now on is going to be 6.2. So we're switching gears a little bit. Not a lot, though. For 6.2, we're looking at graphing exponential functions. Graphing exponential functions.
Homework from yesterday is that we're 6.1.
So I haven't published 6.2 yet. I'm waiting to see how far we get in this class. But I can. Okay. Tomorrow's a work day. Y'all remember that? 6.1 and 6.2 work day. If we can get through 6.2. We'll see. What?
Are you gonna be here?
No. No tutorials tomorrow either. I won't be here.
Why not?
That's why I'm leaving y'all this assignment. I'm taking some pre-cal kids to take a CLEP test tomorrow. It'll be fun. All right, so this is the parent function for an exponential equation. It is just f of x equals b to the x. This is like a toolkit function. This is before we shift it left, right, up, down, before we stretch it, before we flip it, before we do anything to it. These are what they look like, okay? On the left side here, we have f of x is b to the x with b greater than 1. The word that we use when it is greater than 1 is growth. This is exponential growth. As you can see, we move left to right. This gets bigger. It is growing. Okay? This one, b is between 0 and 1. As we move from left to right, it is decreasing. The word we use here is decay. Are y'all familiar with this? Okay. There are asymptotes on both graphs because it hasn't shifted up or down. The horizontal asymptote is at y equals 0, which means the range is from 0 to infinity. Bottom to top, 0 to infinity. The domain is all real numbers, right? It can go from negative infinity to positive infinity. Who can tell me why it doesn't go below the x-axis? Who can remember? Right. These numbers don't output negative. Even if I put in negative exponents, what happens when I raise something to a negative power? It just gets smaller. It's a decimal, right? We're going to work that out in just a minute. But what you should remember, yesterday I taught you about the donut. If I brought a half a donut and then I split it in half, and half, and half, and half, what I ended up with was just really small pieces of donut. I didn't actually end up with negative donut, right? Even when I split it a whole bunch. Are y'all with me on that? Okay. I think that's about it for that. So let's go ahead and start example 1. Example 1 says, sketch a graph of f of x equals 1 over 4 to the x power. They actually write it in the textbook as f of x equals 0.25 to the x power, but I'm much better with fractions than decimals, so when I see 0.25, I convert that. F of x equals 0.25 to the x power. So is this b, the 0.25 part, is that greater than 1 or between 0 and 1? So we're going to be dealing with decay. Okay. The first thing we want to do when we try to graph this is we want to get a table of values. I think that's generally how we try to graph all functions that we're not real familiar with. We try to get a table of values. I would start with like -2, -1. Try to hit your y-axis somewhere in the middle. And then a couple of values to the right of that. You with me? Doing a little input, output. If we input a -2, that means I have 1/4 to the -2 power. How do I raise something to a negative power? Make it happy. So technically I should have 1 over 1/4 to the positive 2 power. Are you following that? Send it to the basement, make it happy. Another way to handle this is to flip the fraction and raise it to a positive power. That's a little quicker. So I have a fraction to a negative. I can flip the fraction and raise it to a positive, which ends up being 4 squared. What's 4 squared? 16. Okay. By the same token, if I have 1/4 to the negative 1 power, that's actually 4/1 to the first power, which is 4. This is only necessary when my powers are negative. If I'm raising 1/4 to the 0 power, it just comes out 1. And wouldn't that be true? Because if I look at my function, what's my a value? Right here, a is 1, which means this sucker should cross the y-axis at 0, 1. Right? We learned yesterday, a is the y-intercept. Okay, let's keep going. Let's raise our 1/4 to the first power. What's the output? 1/4. 1/4 squared. Square the top, square the bottom. 1/16. Good. So if we plot this, 1, you should see that there are sure enough no negative numbers. I'm counting by 4s here. So 4, 8, 12, 16 is going to be way up here. And then at -1, we're at 4. And at 0, we're at 1. And at 1, we're at 1/4. And at 2, we're at 1/16, which is just barely above the x-axis. What happens if I'm at 3? Where do you think that would be? 1/64 would be 4 cubed. 1/64. That's going to be just ever so slightly above the x-axis. Is it ever going to actually zero out, though? No. Is it ever going to go below the x-axis? No. Is this making sense? What's the domain? All real numbers, -infinity to positive infinity. What's the range? 0 to infinity. Good. What's the horizontal asymptote here? Y equals 0. Y equals 0. What do you think, guys? Wonderful? Okay, let's see if we can get a try it. This is going to be graph f of x equals 4 to the x. So now what are we dealing with? Is it growth or decay? Growth. X comma f of x. Let's go -1, 0, 1, and 2. Let's just keep it real short. If I raise 4 to the -1 power, that's the same as putting 1/4 to the first power, which is 1/4. Y'all with me on that? Raise 4 to the -1 power, or I can make it happy and put 1/4. What about 4 to the 0 power? How does that come out? And 4 to the first power? And 4 squared? This is getting out of control pretty quickly. So at -1, we're at positive 1/4. By 0, we're already up to 1. By 1, 4. And by 2, I barely have room on my graph. These things grow so quickly. You might say they're exponential. Oh, sorry. Oh, sorry. What's the domain here? Okay, so negative infinity to positive infinity. And the range, start the bottom, 0 to positive infinity, 0 to top. And the horizontal asymptote. We love? Is love strong? Love may be too strong. We don't hate. Okay. I'll take don't hate. All right, example 2 says this. Graph f of x equals 2 to the x plus 1 minus 3. Golly gee willikers. Now we're doing it. What do you know about transformations? Insiders lie. Outsiders tell the truth. So what are my insiders here? So what do we think this thing's going to do? Well, my base is 2. That's my b. What's my insider? What's with x? 1. This guy. This is the insider. So what do we think it's going to do? Left 1. Left 1. Good. And what is this guy? It's the outsider. Down 3. From our base, which was the parent function, f of x equals 2 to the x. So I think let's graph that guy first, and then we'll shift it. Are you following what I'm saying? So I'm going to put f of x equals 2 to the x power, not 2x, 2 to the x, on a grid or on a table, and then we'll shift it. I just want a couple of points here. I'm going to go point 0, 1, and 2. Just enough that I can drag it and drop it and see what happens. If x is 0 and I have f of x equals 2 to the x power, what's my output? What is 2 to the 0? 1. What's 2 to the first? 2. What's 2 squared? Okay, so let's throw those points on this graph just really quickly. We kind of have an idea here of what this function's supposed to look like before we mess with it. And my asymptote would then be at y equals 0. It's cute. Draw it. Appreciate it. Ooh, ah. Good? Now let's move it. What color? Somebody say color. Purple. Pink. 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 They said pink. Okay. So now we're going to shift it. This function, we're going to shift left 1 and down 3. So we're going to take each dot and we're going to drag it left 1, down 3. Oh, plotting points is hard with this pen. Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. And I have a new function. What's my new horizontal asymptote? It was at y equals 0. The whole function shifted down 3. So now my asymptote is at y equals negative 3. What's the domain of the new function? Still all real numbers. There's nothing that I'm going to do that changes that. It's going to be all real numbers. What's the range of the new function? Negative 3 to infinity, bottom to top. Everybody kind of having a grasp on what we did here? Yeah? Okay. You want to try it? Or do you want to move on? You pick. Move on? Okay. Our next thing is going to be using a calculator to approximate a solution. Okay, so I'm going to write this down for you. This is another calculator step picture. You're going to copy these notes down, and then we're going to talk. Copy as fast as you can. All right, so this is example 3. Example 3, it says use calculator to approximate solution. Use a calculator to approximate a solution. So the problem is this. 42 is equal to 1.2 times 5 to the x power plus 2.8. And what they want us to do is solve. And I will teach you how to solve these by hand later. That is not today. Today, we're going to put one function into y1 or f1. We're going to put the other side into f2. And we're going to find the intersection on the graph. That's the plan. Are y'all with me? So following your steps, you put the left side of the calculator or the left side of the question into F1. So go into F1 and put 42.
Where is F1?
On your graph, home, graph, F1,
Wait,
just 42.
graph?
Graph. And then F1 should be the first entry that's available to you. And in F1, you're going to type the number 42. You got it? And then you're going to push tab, which will take you to F2.
What is
Tab, T-A-B. That will take you to F2. Am I right? Inside F2, you're going to put this function. 1.2 times 5 to the x power. Got it? Well, you could push enter, but you're not going to see anything show up on your graph.
Are you going to add the 2.8?
Yep. Times 5 to the x plus 2.8. Yep. When you push enter, you're not going to see anything really. Am I right?
Yeah.
You don't see the intersection, do you?
Oh.
Okay, so to find the intersection, you got to adjust your window. You're going to go menu 4, which is window or zoom. And then option 1, window settings. And I want my Y min to be 40 and my Y max to be 45. The reason for that is I'm trying to see what happens at 42. And then push enter. Now you see an intersection. Okay, and to find the actual point for your intersection, you do menu 6, 4, menu 6, 4, and it should have you with a little bar that you can move to the left and to the right, and you should be able to push enter. You want to be on the left side of your intersection first, push the button, then on the right side, and then push enter. What number did we get? 2.17, comma, y is 42. Cool? So I'm going to give you one more, and that'll be the last thing we do today. Here's your try it. You're supposed to solve 4 equals 7.85 times 1.15 to the x power minus 2.27. On your window, you don't have to go to y min equals 40 and y max is 42, right? That's not going to show what this picture actually is doing. You could try Zoom Fit. Zoom Fit might fit your equations in your window. It's a bunch of stuff we could do to get you where you can see what's actually happening on the graph. Analyze graph. Number 6.
I click menu.
Menu 6. 4. Intersection.
On the graph? Yeah.
Bryson, what number did you get?
Negative 1.61.
Okay, like that one? Yeah, and then hit tab.
4.
Okay.
Tab. And then on F2.
Did you get the right numbers? Can you check with Petri? Make sure that she's got it going on.
Oh, and then you're gonna get the rest of the equation.
It should fit.
And then
Okay, so that wraps up the end of what we're going to cover today. I will publish the notes for 6.2, the homework for 6.2, in case you want to get going on it. There were a couple of questions that we didn't get to, or a couple of examples, but they shouldn't cause you much trouble on your homework. The homework for 6.2 is really fast. Okay? Tomorrow's a work day. Try to get all of that taken care of. Anybody have anything else that y'all have concerns about? No? All right.